Okay, week two, part two of week two, compound interest. So business maths and stats, I read. So let's pick up where we left off. We just finished simple interest, chapter 5, working through chapter 7 now. And let's go. Compound interest. Well, for this, look, we can use the we'll definitely use the financial calculator. You can use tables, but I recommend the financial calculator or Excel. We will show you Excel in our workshop tutorial class, but let's walk through it. It'd be nice to solve a few things using the financial calculator. We'll just get used to a few buttons first on the calculator. One of the first things we need to do, obviously switch it on, we'll push this button here. And then we want to make sure we're in the right mode. This will do a whole lot of statistics for us later on. So we want to be in normal mode, not stat mode. So we'll press mode 0 for normal mode. Mode 1 will give you stat mode. So make sure we're in mode 0. The other thing that we're going to talk about when we look at annuities is this little BGN/END. Most of the questions we're doing are ordinary annuities, meaning an ending annuity. So if ever you're doing some calculations and you think, wow, I'm getting the wrong answer, it could be that somewhere along the line you've pressed, notice it's gold and it's above the FV key, a future value key. And so somewhere along the line, you might have gone second function FE, which this little letters BGN will appear at the top of the screen when you do that. And it's meaning, oh, you want to calculate a beginning annuity. A beginning annuity is something like a rental payment, which is paid in advance, or a lease, or an insurance policy. So they're the only 3 types of questions that are beginning annuities. Everything else is an ending annuity. Standard loans are ending annuities. So just make sure you go second function FV, make sure that BGN is off the screen. The screen is clear. So far we've hit mode 0. Make sure we're in financial mode. We've checked to make sure there's no BGN at the top. Next step is we've got to clear the memory. What the Sharp calculator will do for you is store a whole lot of these variables. These variables here, N for the number of periods, I for the interest rate, PV for the lump sum investment amount, payment, that's part of the annuities for a regular repayment or deposit, and future value, and then the compute button. So really we're playing with 1, 2, 3, 4, there's 5 buttons all up, but most questions you'll only have 3 variables and need to find the 4th. So the question might say, hey, I've got a certain lump sum today and the number of periods is this and the interest is this. So it might say, hey, I invest $10,000, so you'd key $10,000, hit PV, and then you'd hit, it was in for 5 years, you'd press 5 and press N, and the rate was 8%. Now here, unlike the formulas we were using in the, when you're using the formulas to solve the problems, you use a decimal, but here with the calculator and with Excel, we just key 8 and press the interest rate, and that knows it's 8%. And then we go compute future value. So we've used 3 variables, 1, 2, 3 to find the 4th. But what could happen, you might get a question that says, oh, look, I know what it's grown to. So I know what the future value is. I know what the present value is. And I know what the rate is. But how long, if I knew that, if I want to have $5,000 by investing $3,000 and I know the rate is, current rate's 3%, how long is that going to take me? So you put in what you do know and go compute N to find how long. And the last thing is you might say, look, by the end of 15 years, so you key 15 years in, I want to invest, I've got $10,000 to invest today and I would like to have $20,000. What interest rate would I need to earn to do that? So you key in what you do know, the time, 15, press N. Doesn't matter what order you press them in. You key in the amount you're investing today, 15,000 say, then press PV. And you key in the future value, $20,000. Now here's a trick with Excel and with the Sharp calculator. If we were to key that, if we key that as a positive, it's thinking you are receiving money, positive cash flow. Therefore, the answer it wants to give you is a negative cash flow. You need to pay back this amount. So if you try to make that a positive and that a positive and go compute I, it's going to say error. So just make sure when these have got to go have opposite signs. Doesn't matter which one's positive, which one's negative, as long as one of them's positive and one of them's negative, you'll get the right answer. So let's go back to what we were saying. We were saying, look, we know the time period, 10 years. We know how much we're investing, 15,000, say, press PV. For our future value, we need to make it a negative. So I'll go $20,000 and I'll hit plus minus, and then I'll hit FV. And now I'm ready to go compute I, and it'll tell me what the interest rate is. So have a bit of a play with these buttons. It will make life really, really easy for you. But I started all of this to let you know that what the calculator is doing is it's storing these values in. So the advantage of storing the values in, if you wanted to do a whole range of calculations, you knew N, you knew the PV, and you knew the future value, but you want to play around with different interest rate values, you can go just get this right. Yeah, you knew your PV, you knew your N, and you're trying to find different future values. So what you can do is you can go 3I compute future value, and you've got the future value at 3%. You might go then 4I compute PV. You've got the future value at 4%. You might go 5I compute FE. And so these are locked in. It's helping you. It's making life easy for you when you've got repeat calculations. But most of our calculations aren't repeat. They're brand new questions. So you want to make sure you clear the data out. And so to do that, the best way to clear the calculator is second function, alpha, 0, 0. Press 0 and press it again. So the easiest way to remember it is top left-hand corner, key underneath, bottom left-hand corner twice, 0, 0. So get used to that. At the end of every question, second function, alpha, 0, 0. The other thing I'd love you to get used to doing when you're using the calculator is to use this recall button. So just before you hit the compute button, check what's in here. Check what's in here. And the best way to do that, you've done a question, you've entered N, you've entered I, you've entered the PV and whatever. And so what you do is you go recall N, and it'll come up on the screen. You can see, oh, okay, that's the right value for N. Recall I, oh, good, right value for I. Recall PV, great, it's the right amount there. And if you go recall payment and it's got an amount in there, you go, uh-oh, I forgot to clear the screen. Doesn't matter because you can go, oh, I just put it back to 0. If the payment was showing $500 there, when you go recall payment, say, I'll just go 0 payment, and it'll replace the payment with 0. So you'll get the right answer. And then finally you can go compute FV and you'll get the correct answer. So remember that, recall N, recall I, recall PV, and recall payment. Get all your variables and then go, when you're ready, you know it looks right, you can be very, very confident that you haven't miskeyed anything. You can go compute future value and you've got your answer. So they're the main buttons. There is one other button to play with here, and it's important. It's the setup button, because what could happen is you could go compute I, and the answer you get is 4. But that's because it's not showing you all the decimal places. You would get the answer wrong if the real answer was 3.6%, say. The answer they're looking for is 3.6. But if you've only got one decimal place in there, it'll round it up and show it as 4. So it's important for you to go set up 0 for display, 0, and you press 0 again for the tab. And then I normally go to 4 decimal places, but you can play around with it. Set up 009 if you want 9 decimal places, but 4 should be enough. And that way you'll get a more accurate answer. So let's move in. Let's do some questions. We'll play around. There is Excel. We will use that in the workshop when we get together in the tutorial. So here's the formula. That's the inbuilt formula in Excel and the financial calculator. The compound interest is exponential, raising n, the power n, is essentially that's what's giving us the curve, making the curve. We looked at it last week, how that the future value curve, the compound interest curved up, or the accumulated amount, the future value curved up. And it's the exponential that's doing that. So a market stall owner invests $1,000 in an account. It pays 8% per annum. It's got to be invested for 3 years. We're going to use simple interest, and then we're going to use compound interest. See the difference between the two. Well, simple interest is flat. It's just 1 year's worth of interest, 1,000 times 8%, and then just multiplied by 3. So there's 1 year's worth of interest multiplied by 3, $240 worth of interest, simple interest. Let's go and have a look at the compound interest calculation. Well, he's done it longhand here. He's saying, really, there's 1 year's worth of interest, but now the interest on the second year is not on $1,000, it's on $1,080 at the end of the first year. And then he's building that, he's adding that to say now there should be $1,166 in the account. So he's doing, and then find 8% on that. So he's done it longhand and found, in fact, that we earn $259 worth of interest, an extra $19 worth. Again, for us, I don't know if I've got a calculator on the next slide. I don't. So we're going to see it in the formula. You can use formulas, but they get nasty when you start using annuities. So for us, again, we would go second function, alpha, 0, 0, clear everything out. And then we would put the amount in. I've forgotten the amount. I do apologize, but let's imagine it was $1,000, 1,000, hit PV, hit the interest rate, maybe 3, I don't know if it was 3 or 8, I think it was 8, maybe 8, and press I, and then 3 and press N and go compute future value. If I got the data right, I don't know if I have, you could go recall N, recall I, recall PV, recall payment, make sure it all look good, compute future value. If I did it all right, if I entered the right information, yeah, it looks like I did, you should get 259.71. Here we are using the compound interest formula, if you like. So I'm just going to maybe just do the second part. So really, he's still using S&P. So for me, I would go future value equals FV, future value, FV equals PV outside of 1 plus I to the power of N. And I would put the values in. We're investing $8,000. Notice it's not a regular deposit. It just talks about it as just, suppose $8,000 is invested. There's no more talk of any other money. So it's just a one-off lump sum investment. So we know it's not an annuity. We know what the rate is. And we're going to work, and we're told what the time is. We're just going to work out what the future value is. Oh, it says what's the accumulation factor. Fair enough. The accumulation factor is this. What's going on here? 1 plus the interest rate to the power of 3 is giving us the growth factor, if you like, of 1.157. It's really saying $1 at 5% over 3 years is going to grow to that. So $8,000 must grow 8,000 times whatever $1 would grow to. 9,261 is the answer. And then if it says, well, if the question said, how much interest have you earned? Take your future value minus your present value, and there's your interest of 1261. Just going to move on a little bit. So I think if this is a repeat, I'm not going to do this question. We'll get plenty of time to practice questions in the tutorial. Maybe it is. I've just got to check. It is a different question because it's compounding semi-annually. So we've got to make sure we adjust the rate to match the number of periods. And we've got a rate per annum, but we've got to work out what the rate would be semi-annually. So if it's 6% per year, we're going to divide by two lots of 6 months in a year. So it's 3% per 6 months. And then we've got to convert years to 6-month periods. 10 years multiplied by 2 gives me 20 6-month periods. So now my growth factor is 1 plus an interest rate, not 6%, but 0.03, and not raising to the power of 10, but raising to the power of 20. So we get a slightly different answer. $1 is going to grow to $1.80.6, if you like. So there's our growth factor. This time, same sort of deal, compounding monthly, and it's invested for 5 years. So we're going to adjust 5 to months. So multiply the n equals 12 months times 5, n equals 60. We've got to change the interest rate. Looks like it's 6% again. 6% divided by 12, the monthly rate is 0.005. So again, if you are using a formula, you need to show it as a decimal of 0.005. If you're using your financial calculator, sure, key in n equals 60, but don't key in I as 0.005. We need to move the decimal place 2 to the right. It's actually 0.5%, 0.5%. So you would key 0.5 and then press the I/Y key. And then you should get. So what we could do to solve this, if you want to test this on your financial calculator, you would do this. Second function alpha, 0, 0, top left-hand corner, 1 underneath, 2 down the bottom of the calculator. It's all cleared, all good to go. Put 1 as your PV, work out what $1 is going to grow to. Put 0.5 as your I/Y, your interest rate. Put key in 60 and hit N. You could go recall PV, recall I, recall N to check that you've entered the data correctly. If you have, perfect. Just go compute FV and you should get that answer there. So check that. You might want to pause the video and just practice pushing those buttons. Seeing if there's anything. If there's nothing, notice just a quick thing to point out here. It's more of the same, but it's now quarterly, compounding quarterly. So interest now, notice, watch, you've got to read it really, really carefully. It didn't say, if it had said 4% per annum compounding quarterly, if there was that little PA after it, you'd say, oh, it's an annual rate of 4%, but it's compounding quarterly, so I've got to divide by 4, but it didn't. So you've got to read the question really carefully. It says, no, it's actually 4% compounding quarterly, which is really 16% per year. So please make sure you read your questions carefully or you'll get the wrong answers. Everything else should be fine. Whoops. Now he didn't. Oh. He did make it 1% per quarter. I would not, it's a bit vague. I wouldn't, when I read that, I see 4% compounding quarterly. I would sort of, I read that, I like to see 4% per annum compounding quarter. Okay. So maybe we needed the word, maybe we needed compounding quarterly, 4% compounding quarterly, really. But anyway, so he has read that as 4% per annum compounding quarterly, and that's the reason he's divided by 4. So I don't like that. I really do think you want to make sure you're you're clear in your expression. Maybe you disagree with me. Maybe that question is really clear to you. But anyway, let's see if there's any other tricks. Notice we've got to change 8 years. How many quarters in a year? 4. So 4 8's 32. N is now 32. Suppose the lending industry offers us an alternative deal in which you would earn. Okay, so these getting us to test. So we just do the calculations and go back and match it with the previous example and see which is better. We'll do a lot more practice of this when we get to our class together. Look, the present value formula is just a rearrangement of the compound interest formula, and it's really saying, look, if a dollar earns $1.10 at 10%, earns $1.10 by the end of the year, what present value says is, hey, look, if I knew I was going to get $1.10 at the end of the year and interest was 10%, what's its equivalent value today? So it turns the question on its head, and the answer we get, your present value will always be less than your future value. So we'll get $1 there. So it's a rearrangement of the formula. A plumber wishes to have $30,000 at the end of 10 years. So that is a future value. Bank's currently paying 8% per annum compounded annually. How much does he need to invest today? What's the present value today if I want to receive that future value in the future? So using his present value formula, again, we could use the table, look up 8% and 10 to find this discount factor, if you like. But using the present value factor, it's 1 plus I to the power of minus n. If you keyed that in your calculator, there is a little shift gold key and y to the power of x. You could raise that to the power of 10. We'll do that in class. We'll make sure for those that would like to check things on there and use a formula, we'll show you how you can do that. But let's do it the easy way using your calculator. Now, again, I wish I should really, in class, we'll actually practice with the buttons. I'm just going to get you to imagine, I'm going to talk you through the buttons. If you've got the calculator in front of you, that's great. So I'll calculate a second function, alpha 0, 0. $30,000 is a future value. So we key in $30,000 FV. The period is 10. 10 is my N. 8, it's compounding annually. 8 is my I/Y. So press 8 and then the I/Y key. We just need to find out what it's going to grow to. Compute FV. And we get the answer of $13,895. We could prove that in Excel. We could prove that $13,000 would in fact grow at 10 years at that interest rate. By the end of the time, we'd have $30,000 in our account. Again, that's another little activity that you could see. It's nice to see it line by line by line to see the compound effect of that $13,000 growing to $30,000. Just going to check if there's any other little tricks here. It's good. I think it's all right. So yeah, it gets nasty if you're relying on your calculator to do the calculations. You've got to find the nth root, and look, it's doable, but it's painful. Why not let Excel or the financial calculator do the hard work? We'll do one. We'll do one of these tough questions in class, but after we've done that, we'll find easier ways of solving them. So I won't do that now. We'll do that when we get together in class. And again, if we wanted to solve for the number of periods, the only real way to do it, other than trial and error or goal seek, is to use logs. And so that gets a bit nasty. You can do it. We can show you how to do it in class. We might do one if we've got time, but you know, why when you've got some great tools like Excel and your financial calculator to do it for you? Nice to see, I suppose, what's going on, understand the mathematics behind it. You can imagine the guys, it wasn't too long ago, people were solving these questions using a slide rule or using log tables. Just checking if there's anything else we need to do here. This is a how long style question where we needed to use logs. We might crunch that, you know, if we're in a good mood next Tuesday. Yeah, let's just imagine I'm trying to use the calculator to do that. So he wants to make sure he's got $8,000 in the future. So that is FE, and he's currently got, there's my PV, $6,200. And under plan A, he'd be paid simple interest. Forget simple interest. We're just going to focus on plan B, an annual interest rate of 4.8 compounded monthly. So with the financial calculator, we'd go second function alpha 0, 0. We'd key in $6,200 PV. Now press the PV button. Now remember I said that we can't have both of them being a positive. So I've entered that as a positive. I need to enter my future value as a negative. So key in $8,000, then go down right down the bottom of the calculator near the 0 there. There's the plus minus button. Hit that to convert that to a negative. Then hit your future value key. Then we've just got to put the interest rate in. We'll go 4.8 divide by 12 equals, and then press I. And the answer we get will be 63.85, but that will be months. It says how long. It'd be nice if it said how many years. We would really want to convert it to years, because this answer in years, let's convert it to years to make sure we can compare the two. And so we would just divide by 12. So 5.32 years, a little bit quicker. That's it. I'm going to stop the recording there, and we'll do our third session on annuities when we get back together in a moment.